Hello, everybody, and welcome to yet another OpenShift Commons briefing. This time we're getting an update on Kubernetes 1.11 or 1.11, depending on how you want to talk about it, from Josh Berkus and Stephen Augustus, both Red Hatters, who have very specific roles with the 1.11 release. So I'll let them introduce themselves and get us rocking and rolling here. We're going to have questions in the chat if they're really good ones. We'll interrupt. If otherwise, we'll save them all for the Q&A at the end. All right, so let's get going.
Great. Thanks a lot, Diane. So I'm Josh Berkus. I'm the Kubernetes Community Manager for Red Hat first, which is every one of the companies that's heavily invested in Kubernetes assigns one or more people to be community managers, because as a project with over 1,000 contributors, we actually kind of need our own administration, and we have that, but it takes people. The other, relevant thing to 1.11 was I was the release lead for Kubernetes 1.11, and the way that works is members of SIG release volunteer on a quarterly basis, because we do one release a quarter, to fill various roles on the release team. And that rotates every quarter to avoid having people burn out, and also because it's a good way to train people up. And so I spent a couple of releases as bug triage lead, and then moved up to release lead, and now I'm taking a quarter off the release team. Stephen?
Hey. Stephen Augustus here. I am a specialist solutions architect for the OpenShift Tiger team at Red Hat. My community roles, so I was working with Josh on the 1.11 release team as the features shadow. I am actually the features lead for Kubernetes 1.12. In addition to that, I run one of the chairs for SIG Azure, and I am a product management chair for SIG PM.
And so, by the way, what you're seeing there on the title slide is one of the things that we do in the release team. Is it's customary for the release lead to pick a cute theme for the release that really gets used only internally at the release team. So for the 1.10 release, that theme was Left Shark. For the 1.11 release, I couldn't pass up the number and gave it the theme a long anticipated release, as in a reference to The Hobbit, per the drawing on the screen. So 1.11's been out for
about a month
almost
now?
a month now.
Yeah,
3 weeks, I guess. Seems longer, honestly.
Yeah. When you're in the thick of the release cycle, it definitely does.
Yeah. So actually, this is a little bit out of date. I prepared these slides earlier. We did actually release on June 27th. The release was delayed one day by having some indeterminate test results on our test board. And we just wanted to give it an extra day to make sure that the tests were going to pass, because we have a lot of important end-to-end and performance tests that can take half a day to run. My prediction that 1.11.1 was going to come out within 2 weeks was pretty much correct. It's out now. If you are already using 1.11, then you should update to 1.11.1, because we fixed a couple of important things that we honestly discovered within a day of the release. One of them we discovered the day before the release, but we decided not to hold it up. And that was the inability to restrict users from prioritizing their tasks as system tasks, which is kind of a problem if you have badly behaved users. And in 1.11.1, you have an ability to do that. So I have a list of 6 features here. But as Stephen was the feature shadow for 1.11, he'll probably have some additional ones that I didn't think of when I put these slides together. But let's talk about these 6, and then we'll probably throw in a few others. So one of the first ones is, for the last 3 or 4 releases, I don't know how long we've had kubeDNS since kubeDNS replaced something else, whose name I've now already forgotten.
Is it SkyDNS?
Was it Sky? I think it was SkyDNS.
Right.
So, for those of you who actually have not used OpenShift actively or Kubernetes before, one of the things that you have to provide inside a container cluster is directory services, right? You have to know where your various services are, and you have to be able to redefine that dynamically as you move containers around the cluster. So DNS is kind of a critical part. Now, this has always been pluggable via an API within Kubernetes, but for that matter, we've always had a default one that we recommend, and that a lot of the Kubernetes installers install by default. Now, for the last 3 or 4 releases, that default has been kubeDNS, a particular open source DNS thing built for Kubernetes. We are now we're not switching the default yet, but as part of the plan of switching the default, CoreDNS, which is a smaller, lighter, simpler, but still completely dynamically configurable DNS server written in Go, has now graduated to the thing to where it's installable as your DNS just by a small configuration change in most of the installers. And one of the installers, that is kubadmin, installs it by default on any new cluster, although not on an upgraded cluster.
Right.
What DNS are we using in OpenShift 3.10?
So we're continuing forward on the community path. I believe we're gonna be looking at CoreDNS moving into 3.11 4.0.
Yep. By the way, for anybody who hasn't played with it, one of the things that happened after this became a feature on the features board was I checked out CoreDNS. I actually run a DNS, server on my laptop so that I can fake out things for demos, etc. And control other hardware in my office. And I actually switched that to CoreDNS because it really is very nice. And you can get a working DNS server in a little tiny configuration file with like 5 lines of JSON. So check it out if you like monkeying with network stuff. The second one, this is actually honestly the feature that I personally am the most excited about from 1.11. Everybody has their favorite feature or whatever. So I do a lot of bare metal stuff because I have a long history of, in the pre-cloud days, and then for that matter, one of my things is databases on top of Kubernetes and OpenShift, and that often means bare metal environments. So one of the ongoing headaches that we had for Kubernetes administrators was that if you needed to make a configuration change to your kubelet, like, for example, change, what do you want to do dynamically? Change where the PKI files were located. Yeah, go ahead.
Our maximum pods per node, something like that.
Mm-hmm. Or the memory allocation per machine or things like that. If you wanted to change one of those, the only way to do it was to actually restart the kubelet on the server with separate configuration with different flags, startup flags. And this had two really annoying issues with it. Number one is, for even a fairly minor configuration change, like for example, you wanted to increase the maximum number of pods per machine because you realize you're not actually using all your system resources. That means that you're having a rolling blackout on your cluster in order to do that. And when you do that, Kubernetes is going to shift a whole bunch of the pods around. It's going to shift them back. And so you have a lot of service degradation while that's happening. Second issue is that on a lot of Linux systems, that means that you are then modifying the systemd configuration file for the kubelet, which is a kind of irritating thing to do from a configuration management standpoint. And so that's been changed. So now what's happening in kubelets with something called dynamic kubelet config, which has two tremendous advantages. One is some configuration things like maximum pods per server can be changed dynamically on the fly, well, with the kubelet running. And the way that you actually do that is there's actually a config map for the nodes and for each node, and you can actually modify settings in that config map, and at some polling delay, the kubelet will pick those up. Which means that you can make some setting changes without ever leaving the Kubernetes system or OpenShift system once OpenShift wraps this feature. And the second thing is we've moved the kubelet configuration to an actual configuration file instead of using startup flags. And so for people who are managing their kubelets via Puppet or Ansible or something else, having that separate configuration file actually makes it easier to manage.
So, Josh, I'm curious,
Yeah.
Around your bare metal clusters, do you plan to adopt that anytime soon? Or have you been using
dynamic kubelet config?
Yes.
Yeah. I mean, I played with it. I mean, the truth is that my bare metal clusters are all for testing purposes. So I haven't had that many reasons to tinker with that. Although if I get serious about the performance testing that I'm doing, I will have reasons to use that feature a lot more. And that's as I've wanted to complete a set of performance tests I've started where I'm testing running a database benchmark on top of Kubernetes with various configurations of storage. And that's to answer the question people, because like I talk to a lot of database people because of my history. And one of the questions they say, look, we can accept that running our database on Kubernetes will result in an increased latency and maybe some limitations on throughput. That's okay. We need to know exactly how much, though. We need to know how much does it increase latency, right? What is the throughput limit, if any? And so I want to put some numbers behind that. And so I've actually started doing some testing. And the idea is to test just database on bare metal, which I already have for those numbers, and then to test Kubernetes with local storage, and then Kubernetes with various forms of clustered storage. So Gluster, something Rook-based, et cetera, so that I can actually get an idea of what those numbers look like. And then publish them.
Sounds great.
Yeah, and I expect I'll be using the Kubernetes, the dynamic kubelet config will be useful in that because I'll be wanting to change settings when I change storage.
Right.
Yep. By the way, if you want to jump in here and talk about any of these features, go ahead.
Yeah, sure.
Features when are on.
So why don't I take this one? So with Kubernetes 1.11, we see improvements to CRDs, which for those of you who are aware, it's custom resource definitions, which used to be third-party resources or TPRs. So extending, what we've done here is we've extended the functionality of the CRD API, one to include versioning, and secondarily to be able to actually track sub-resources, right? So the reason that two of those are important, so one, versioning, classically in CRDs, writing a CRD would involve knowing a set of API types and kind of mapping out this entire config for your application. What happens there is, as we move through different versions of Kubernetes, the APIs may change. What you'd like to be able to do is have a Kubernetes native way of of expressing what your app does, right? So versioning the same way the V1 alpha 1, V1 beta 1. So following that ability to version the same way Kubernetes does allows us some niceties in planning around building your API. So on the sub resource side, the reason that having the functionality to manipulate sub resources as opposed to top level CRDs is several applications will take things like we'll watch things like status. So there's a status endpoint as well as a scaling endpoint. So when you're building out your application, you want to be able to certain applications don't need the same level of access to a CRD, right? If you provide access to the top level CRD, you start to introduce these security implications, right? So if my application is able to manipulate a CRD in a certain way, is that dangerous to the cluster overall? Is that dangerous to the namespace, right? So being able to watch these sub resources instead. So just maybe I have an application that just needs to query the status of a CRD as opposed to manipulate the entire CRD, right? So bringing that functionality in is really, really crucial. The reason that I'm pretty excited about CRDs is being a former CoreOS field engineer. All of the work around building operators as well as the operator framework, we start to see more and more of that ability for people to really manipulate clusters and build applications for Kubernetes, and building around that operator pattern. We need more and more functionality and providing, being able to provide means to build applications in a safe manner is always one of the foremost goals for Red Hat, for the community. Yeah, I'll stop mumbling.
Yeah. Yeah, and so I mean, to be clear, because I'm sure if people have been following the OpenShift briefings, you've heard a lot about operators, and so most operators wrap a CRD as part of their functionality. So if you hear us talking about CRDs, this is a critical piece of what makes operators work.
Thank you for inserting that. That was perfect timing. Yeah. There's a lot of briefings on operator and the operator framework that we have that you can look up. And there's also an operator framework SIG if you're interested in learning more about operators.
Yeah. So one of the other ones, and this one has been very important, I know, to the OpenShift team because of the need for enterprise production workloads to have this functionality, is priority and preemption. And so priority is the ability to give pods and jobs, in the case of like cron jobs, different priorities in terms of how important it is to run them. And then preemption is the ability to say, hey, this is a really high priority pod. I want you to run it even if it means kicking other pods off the node or off the cluster. And there's a number of reasons why you would need to do this. There's the first one in that you may have background jobs that you want to run whenever there's spare capacity, things like reporting stuff, etc., cleanup stuff that you want to run if there's spare capacity, but you want to get bumped off of the cluster whenever there's not spare capacity. You may need to run a debugger or a diagnostic tool when the cluster is overloaded, specifically to find out why the cluster is overloaded. And if the cluster is overloaded because one of your microservice pods is performing very badly, you want to be able to prioritize the new replacement pod so that it will bump the old ones, even though the cluster does not have any, spare resource capacity. Then there's a number of other things you can imagine. So, so this is in beta, which means it's on by default. And this is actually where we needed the fix for 1.11.1, because the two highest priorities are node critical and system critical, I believe.
Right.
And initially there was
and system node critical.
Yeah, and initially there was no restriction on anyone who had had the ability to create pods from using those. And it was quickly pointed out that that would allow users to accidentally take down the cluster just because they're trying to prioritize their jobs. And so now there's a restriction on that.
Yeah, so essentially kicking out critical functionality like let's imagine the API server or the controller manager, or the scheduler. So
Yeah.
so huge fix.
Yeah, and in alpha, and therefore not on by default, and then going to be in beta in 1.12, there's a more sophisticated system of access restriction for priority and preemption as part of Kubernetes. So, so you'll be able to actually specify which priorities specific users can use. I have a limited amount. How much do you know about the changes with adding extra Windows features, Stephen?
I'm pretty limited on that side too.
Yeah.
So I know it's been incremental improvement across the last few release cycles. So I would imagine in 1.13 or so we might see a full feature set for Windows plumbing.
Yeah, that's actually what SIG Windows told me. They said 1.13 is their target for having complete Windows native Kubernetes.
Woo! So I'm doing my job, okay.
Yeah. Yep. So yeah. Other than that, neither Stephen nor I actually use Windows, so it's all academic. The way that I know that there was a lot of work in this is that I get to see the PRs merge, and I see how much work they're doing on it. But I often don't even understand the changes. So this is a fun one. Do you want to take this, Stephen, or should I do it?
We can tag team it. You can start off.
Okay.
Jump in.
I mean, the big thing with this is enabling being able to use IPVS, which is a Linux kernel feature, in order to do load balancing.
Right. So classically, Kubernetes. So the service resource in Kubernetes by default uses a set of IP tables, rules, and netfilter. So what you see in clusters with a large amount of services, a large amount of pods across multiple nodes, essentially what's happening every time you build a service is I'm writing, that service is a proxy to a set of pods, right? So I'm writing a set of IP tables of rules that says, hey, if you're looking for service foo, these pods are the ones that hold service foo, right? So as we start to see more services enter the cluster, as well as more nodes, those IP tables rules get longer and longer and longer, and there hasn't really been an efficient way to scale that, right? So the secondary option for using services in Kubernetes is to implement via IPVS. So as Josh was saying, IPVS is in-kernel networking. It's built essentially using a hash map instead of a table. So what that allows for is quicker lookups of these rules, right? So you have one, it's happening in kernel. Two, we have faster lookups, and it's much more lightweight than building a set of IP tables rules. So what we'll start to see is people switching over to this rather quickly. I believe we're planning to do this in, I want to say 3.11.
Yeah. It's nice. I mean, this is definitely nice, again, for bare metal geeks like me, because, mostly for bare metal setups, I've been kind of subsisting on just using round robining
Right.
for all the services and everything. And with IPVS, I have the option of doing more sophisticated load balancing. which
Right.
when you look at things like having OpenShift host a database where you may have you may want to do more sophisticated things with your load balancing. Like, for example, you might have a write connection that goes only to the master and a read connection that gets load balanced among replicas, and ideally only replicas. And with the service round robining, you don't have the ability to be that specific.
And around around stateful applications too. So one of the options for IPVS, I believe, is you don't you have the ability to like Josh was saying, have more sophisticated routing techniques, right? So in addition to round robin, you've got things like least connection. Something for a stateful app that might be super important is being able to have a sticky connection to a database, right? So we'll start to see that come into play.
Yeah. Okay. Obviously, RC1 and that sort of thing. These are all. Sorry, I did the set of slides for an earlier briefing. Let's. So you were feature shadow. So are there other features you'd like to mention that weren't included in that initial list?
So just a call out to SIG Azure. I'll do what we've seen is lots of improvements around the Azure support, one in cluster auto scaling as well as VM scale sets, right? So one of the biggest features of having a Kubernetes cluster is that you get to consider these commodity nodes, these homogeneous set of nodes. So classically in environments like AWS, let's say, right, you might spin up an auto scaling group, and that would be what backs your worker nodes. Now in Azure, the constructs are slightly different. So the idea of an availability set versus a scale set. So a scale set is analogous to an auto scaling group in AWS. So what we had before on the Azure support side in Kubernetes was support for availability sets, which means you have to essentially configure each of your nodes in a certain way so that it's able to pick up the kubelet and join the cluster, as opposed to being able to declaratively define what your nodes should look like in a template and being able to spin up nodes based on that, and obviously having the niceties of being able to scale up and scale down. So across 110, 111, and we'll see even more improvements in 112 around bringing scale set functionality, new load balancer SKUs, and overall support for cluster autoscaler.
So speaking of 112, you are the features lead for 112.
That I am.
And feature freeze is in 4 days?
Yes.
On Monday, I guess? Tuesday?
Yes. Tuesday.
So what's already on the list? Is anything already on the list?
We've got to give me a second. Let me actually pull up the list. So anyone who's interested in viewing this list, I will pop it in the chat as well.
Yeah. Maybe share it on the screen and walk.
Okay. Yeah. Here.
Take a look.
I can do.
Yeah.
As soon as I actually figure out how to exit this, there we go.
Let me do some screen cleanup. And to that question about the K11 features, I will get the link in a second.
Oh, okay. We already got, yeah.
We got some chat questions popping up.
No,
so one of the ones I'm really excited about is starting to see more work around TLS bootstrapping. So this is, one, not just bootstrapping, but also certificate rotation.
Okay. So can you see the grid there?
I can see it, yes.
Okay. Oh, now we got the usual problem with the gigantic header. Is there any way I can make this header go away so that people can actually see stuff?
I believe you should have access to hide it. Hold on, I can do it though. Just for the call.
Well, that's not really responding is the problem. I think the combination of screen sharing and this is not allowing me to actually have full.
Yeah, just slide down.
Oh, there we go. There we go.
Boom.
Just not.
There you go.
It's not, okay. So, yeah.
And I think
okay,
if you
so
do Control-Shift- or something, you might be able to minimize a little bit just to get a zoomed out view.
Yeah. Okay. Oh, right. Debug containers are coming back. That was supposed to be a 1.11 feature and had some issues and didn't quite make it. So.
Yeah, debug containers are coming back. The AWS network load balancing is pretty cool. But yeah, TLS bootstrapping, that was a problem that we were pounding at CoreOS, definitely at Red Hat. So to see some of that start to coalesce, so around TLS bootstrapping as well as certificate rotation, I believe that's going to be a separate feature that's already in progress.
Yeah, and node level user namespace remapping is part of our path to. One of the things that OpenShift requires is that you can't run in your container as the root user in the container because there's a number of security exploits that are possible if you are. But the drawback about this is that you end up having to redefine. If you pick up a container that was designed for a different environment like Docker, you end up having to redefine it for OpenShift. And if the container contents need to run as a specific non-root user as opposed to a random non-root user, you have to take even more extra steps. And so user namespace remapping is actually the fix for that, the way to make it elegant and easy to maintain. And so we're on a kind of slow road to enable that. Part of why it's slow is that I don't know how long ago user namespace remapping was added to the Linux kernel, but a lot of people are running Linux kernels that won't support it. So it'll be an option for some people for some time, fortunately. But that is our solution to making sort of non-root containers more secure without making them quite as annoying to create as they are now.
So so around feature-wise, we're going to see more improvements in storage. So the CSI container storage interface will kind of get buffed up. There are a few. I mean, this has been happening across the I want to say the last 3 releases or so, and it will continue forward probably to I want to say 1.14. So improvements around CSI, being able to do things like having topology support. So building in the constructs of am I in a certain region? Am I in a certain zone? Am I it's building the ability to be data center and rack aware. So you can start to understand where your storage lives and
Is there a row you want me to scroll down to? Oh, right there. Kubernetes topology support. Down there towards the bottom.
Yep. Yeah.
There's actually, and then there's supporting things.
Right. So there are tandem proposals for essentially figuring out topology and how to approach that. We on the Azure side, we recently merged a KEP, which is a Kubernetes enhancement proposal for building support for Azure availability zones, right? So again, same construct in AWS. You've got regions, you've got zones. Across the zones are essentially different data centers within the same region, right? So having the ability to understand where nodes in your cluster actually live across, say you don't want a node in zone 1 trying to claim storage that lives in zone 2, right? You've got latency concerns there, and it's an overall application performance issue, right? Let's see what else is interesting. So we were talking about CoreDNS. We'll see CoreDNS move to already GA, but we'll see it move to the default in Kubernetes 1.12. Hopefully, fingers crossed. I think everything should be fine. Yeah. The KubeADM guys are going to be doing a lot of work around testing that out by switching it to default. So thank you for jumping ahead and and making sure that support is vetted for the community.
Yeah. I knew some of these. So gang scheduling is a performance improvement for very large clusters. In that, if you have a very large cluster, and here we're talking about like over 1,000 nodes, 1,000 physical nodes, and you're scheduling hundreds of pods at a time, in current Kubernetes, you find yourself actually honestly limited by serialization in the controller. And so the folks in SIG-Scalability, trying to remember what K82 translates to in terms of a real person's name.
Klaus Ma.
Oh, Klaus Ma, right, particularly Klaus Ma, have been working on a way to say, hey, if I'm deploying 50 of the same pod at once, I should be able to actually do this in parallel across nodes. And so this is part of their work on batching and parallelizing things so that we can have a greater throughput in terms of deploying and updating pods on very large clusters.
So what else is kind of cool? The IPv6 dual stack support.
Yeah, true. Yep.
So pending inclusion for you guys who are curious about how we maintain this sheet. Pending inclusion basically means this was something that was planned. We're waiting to get just a little bit more feedback from the people who own the feature to ensure that it's actually going to be part of the milestone. So features is part data entry, part cat herding, part part pinging on features. So yeah, we're just waiting to get feedback around what's going to happen before we actually mark that as tracked and kind of maintain this sheet across the release.
Yeah, and for realism, historically, for what we've had in tracked features for an individual release, by the time we hit beta, usually 30 to 40% of these have been postponed to the following release because of whatever issue they ran into that they didn't expect. And we tend to get 3 to 4 additional features that were not tracked
at the end.
Yeah, well, because usually they weren't tracked because somebody didn't think they were going to be ready in time, and then they had a slow week at work, and they're like, well, I'm going to put in 20 hours working on this and get it ready.
Yes. So just a note around, for the viewers at home, a note around features that kind of meet that mark that Josh was mentioning. We actually have a features exception process. That's where the owner of a feature will have to file an exception, let us know the amount of time that it's going to take to include that feature in the release, and why we think that, and why they think it should be included in the release. Right. So there is a process around vetting late coming features, which gets approved by the release lead. So Josh, I believe we had maybe 2 or so for this one. Wasn't too many.
For 1.11, there were 3 that I recall.
Okay, all right.
So
can you talk a little bit about the timing for all of this? So this is 1.12. So what is the expected release date of 1.12, and where is that timeline information, and when things are pending like that, and when are the cutoffs for that kind of stuff?
Yes, I think Josh is actually pulling up the SIG release, right? So SIG release is is the repo that we maintain all of the documentation. We try to make sure all of the documentation around releases is housed there. And Josh is pulling up the timeline for 1.12.
Yeah, so here's the timeline. Obviously, there can be delays, but this is the planned schedule. And we're actually honestly pretty good about this. Like even 1.10, which had a number of really bad problems towards the end of the release, was only delayed by about 8 days. And
for reference, that's why that release was called Left Shark. That's part of the reason.
Yeah. So, I mean, I think you can reasonably expect that if we don't actually hit these dates, we won't be more than 2 weeks off.
That's July, August, September 25th.
Yeah.
So that's the general target for Kubernetes 1.12.
September 25th.
The 25th. Yeah. So I mean, the first month or so, which is what's happening right now, we'll see. Essentially, it's the features collection process, right? So that I tend to be a lot busier during the first third or so of the cycle, and my role tapers off a little bit. It's a little bit maintenance mode, following up on things that have slipped towards the end of the release cycle. So what we're doing right now is features collection. That's me filling out the spreadsheet, contacting people, making sure that features are properly vetted and the right people are plugged into the feature tracking repo. So Josh, if you don't mind pulling up the features repo as well.
Okay.
Right, so this is Kubernetes/features for anyone who is curious. I'll post a link to both of those as well in the chat.
It helps if I spell Kubernetes correctly. So this is the features repo. I suppose we want issues?
Yes.
Okay.
Right, so
would you please stop showing me the stupid banner? Okay.
Don't you want to join GitHub?
Yep. Do we want a milestone?
Yeah, let's do milestone. Right. So what that'll allow you to see, if for anyone who's curious, is all of the features that are tracked for essentially slated for 1.12 are insert milestone here. So yeah, everyone who submits a feature to this repo is expected to have a requisite amount of data, including whether or not there are docs or tests, where the proposal lives, what's the expected timeline, moving through different stages, and also you can see these brown labels for the SIGs that own each of the features. So
you would actually look at one here.
Yeah.
It's really, a lot of the information is really very, very accessible. You just need to know where to find it. And I think that's what's really helpful about the conversation you guys are guiding us through today. And it'll help us with some of the future releases too, when we watch and try and see when they're going to show up in Kubernetes, how they get surfaced and released into Kubernetes, and then watching them in OpenShift for the OpenShift release cycles too. So there's a whole series of almost a domino effect for these things to get out into the wild, into OpenShift, and then again into OpenShift Online and dedicated and OCP and the different releases. So it's very, I think it's amazing how the whole release process works for Kubernetes, considering how many different parties are involved in getting these things up. And as Stephen mentioned, and Josh actually mentioned it at the very beginning, each of the organizations involved pretty much now has a community liaison manager assigned to the Kubernetes project, and that's really one of the essential communication conundrums of large projects like this. And I think this is pretty much a testament to how well the Kubernetes project has been working and collaborating together. So this has been really very interesting, I think, to see how this all works, and hopefully we can get you guys back for each ensuing release and work it out. And I think this would be a really great reoccurring topic to have with each. So thank you very much for bearing with us if you've been listening since the beginning. I will make a few edits to the video for continuity, shall we say, and make it available on our YouTube channel as usual, and as a blog post with an embedded video on blog.openshift.com later today, or maybe Monday morning. But this is an invitation to Josh, and that one of the things that I've really wanted to do is to ask the different, not just Red Hat or Kubernetes SIG leads, just to have maybe a reoccurring different SIG lead talk to the OpenShift Commons on some sort of reoccurring basis on Fridays. Maybe the beer o'clock talk, depending on where you're living. So I'd love to do that, because I think it really helps inform and do some expectation management as well for the OpenShift community as to where things are coming, and it gives visibility to how much of what was probably in the earlier releases of OpenShift, where the engineering effort is going that Red Hat is doing, is because Red Hat's putting a ton of the engineers who used to, plus more, work on OpenShift, are now actually working directly on Kubernetes, such as yourselves and a myriad of other people. And really, this is, and OpenShift is a distribution of Kubernetes, and it is a huge collaborative effort. So I'd love to showcase some of the people and some of the work that's going on in the SIGs in some sort of regular format.
Yeah, cool. I mean, that would be great. I can help rally some of that stuff as well, Josh.
Okay.